power curve is a graphical representation of our aircraft's airspeed and the required horsepower to attain said airspeeds. Being on the backside of the power curve means that you have gone slow enough that you will actually need more power to stay afloat if you started to slow down. The reason why we don't run our engines at wide open throttle for cruise is because it actually decreases fuel mileage and it greatly reduces the life of our engine. And you can see in this picture here that the top line is the power available and the curved line is the power required in order to maintain straight and level flight. And obviously they meet at 2 points. Alright, so the next picture you see is the VY speed. At VY, the excess horsepower change of P is the greatest, resulting in the maximum rate of climb. And then the next picture that you'll see is VX. That's at the point at which the RC line touches the curve and results in the best climb over a given distance. And both the VX and VY speeds will increase with altitude because of the air density decrease as you gain in altitude. And then one thing about the VY speed is that it occurs at around 68 knots in our Skyhawk. Just a little fun tidbit there. And then the performance is decreased so much in a twin engine aircraft with one engine failure because of all the horsepower required to maintain level flight is put on one engine, severely reducing the climb performance. And then in this picture we see the minimum sink rate is shown on the graph where the change in P is the smallest. However, it doesn't mean that it is the best glide speed since the aircraft is moving at a small forward speed. And then this is actually the BG representation at the minimum ratio of rate of sink to forward speed. And here we see the maximum range of the aircraft. It occurs at the maximum LD max ratio. And one thing to note is that most aircraft cruise much higher than this.